Chemical equilibrium. Equilibrium means that the rate in the forward direction equals the rate in the reverse direction. Let's consider an actual chemical reaction. So here I have the chemical reaction for the production of ammonia, NH3, from its elements, dinitrogen, N2, and dihydrogen, H2. And this is the balanced equation. The rate in the forward direction is equal to the rate constant in the forward direction times the concentrations of all of the reactants that are either in the gas phase or the aqueous phase, that is, anything that is not solid or liquid. So everything here counts, raised to the power of their coefficients. So concentration of N2 to the first power, because that coefficient is understood to be 1, times the concentration of H2 to the third power. The equilibrium constant in the the rate equation in the reverse direction, RR, is equal to the rate constant, KR, in the reverse direction, times the concentration of NH3, the product, raised to the power of its coefficient, 2. And again, you only include stuff that's in the aqueous phase or the gas phase, but not solid or liquid. So now we're setting these two expressions equal to each other. So we have Kf times the concentration of nitrogen times the concentration of hydrogen cubed equals Kr times the concentration of ammonia squared. The rate of the forward reaction equals the rate of the reverse reaction. Now we're going to divide both sides by Kr, and then we're going to divide both sides by concentration of N2 times the concentration of H2 cubed. And we get Kf over Kr equals the concentration of NH3 squared over the concentration of N2 times the concentration of H2 cubed. And that is equal to the equilibrium constant, KEQ. In general, we can say that KEQ, and note this is an uppercase K, equals the concentration of products raised to their coefficients over the concentrations of reactants multiplied together and raised to their coefficients. Now, let's think about it. Let's say you have more products at equilibrium than reactants. That would give you a KEQ greater than 1. If you have the amount of products about equal to the amount of reactants, then your KEQ would be equal to 1. And if you have less product than reactant, we'd say your KEQ is less than 1. These three cases are considered product favored, reactant favored, and the case in the middle, neither is favored. And I just want to take a moment to make a definition here. The law of mass action. We've already seen it, but here's what it says. If you have a chemical reaction where A moles of reactant A reacts with B moles of reactant B in a reversible reaction to make C moles of product C and D moles of product D, then the equilibrium constant, KEQ, equals the concentration of C to the Cth power times the concentration of D to the Dth power over the concentration of A to the Ath power times the concentration of B to the Bth power. Right? That's multiplying together the concentrations of products raised to their coefficients over the same multiplication, concentrations of reactants raised to their coefficients. Just for the record. Here's an exercise for you. Nitrogen dioxide interconverts with dinitrogen tetroxide. Can you write the equilibrium constant expression? Pause your video and work it. And here's the answer. KEQ equals the concentration of N2O4 raised to the first power, so you don't have to write anything in, over the concentration of NO2 raised to the second power.